Okay, so today we're doing 1.4, which is day 3 and our last day of 1.4, the rational expressions. So by the end of today, you're going to be able to add and subtract rational expressions and simplify complex rational expressions. So sometimes people have trouble with the common denominator, and we have to end up multiplying and then adding and subtracting all together. That's why this is something that we are doing together, even though you have done this in Algebra 2 and probably also in FST if you were FST. So when you're adding and subtracting a rational expression, you do have to have a common denominator because a rational expression is still just a fraction. So whenever you have a fraction, you have to have a common denominator. Now, any common denominator is going to work, but it's always best if you use the least common denominator. If you don't, you'll have to simplify at the end. So how do you find the least common denominator? We're going to write it down in words, and then we're going to talk about different strategies as we do our examples together. So we're going to factor each denominator, which you guys would have done a lot of factoring yesterday. So we are going to have more factoring today. And then once you factor, you're going to take the product of the distinct factors. And we're going to use the highest power that appears in any of those factors. What that means is if you had x cubed and x squared, the highest power would be x cubed, and that's what would have to go in your LCD. Okay, so when they're talking about the highest power, you have a factor that has any power, you have to use the highest one. Sometimes you might have like x minus 2 squared. So then if you had 1x minus 2, you would have to use the squared in there. You can see that I underlined distinct. Okay, can you tell me what distinct means? Think about if you want to distinguish yourself from somebody else. What does that mean? Yeah, different, unique, right? So when we're talking about distinct factors, we're just talking about different factors. They can't be the same. Okay? All right. So for example 1, we are going to perform the addition or subtraction and simplify. And I'm going to let you write down both of those problems. Again, this is something that you did in Algebra 2, so you might find that you can do both of those without me, and that's perfectly fine. There are a couple of notation things that I'm going to go over, so make sure that you have those notation things intact. And remember that your quiz over 1.4 is on Friday. Whenever you have like a test or a quiz coming up, just notice that I will write it under the agenda for the day. Okay, so if we're performing the addition or subtraction, first thing we have to do if we're going to add or subtract is get a what? Common denominator. All right, so this is the way that I do the LCD. And really, these couple problems are pretty mild when it comes to the LCD. But once you start getting into powers, it can be a little more difficult. So for the LCD, what I do first is I just look at the denominator of the first one, and I put that as part of my LCD. So x minus 1 has to be part of my LCD. Okay, for x plus 3, if that's not already included, then I have to put that down next to it. And then those are the only two things I'm adding together, so that's going to be my LCD. Now when I talk about the notation, that's going to be important when we do our next step. So in order to get the LCD, CJ, what am I going to have to multiply the first term by? Yes and no, because I know what you mean. One part. Yeah, Joey? Okay, yeah, and why am I being picky about that? Why am I being picky about that? Okay, yeah, so a lot of times, yep, and CJ, I'm glad that you said that, because a lot of times people just write this, right? X minus 1. You can't just multiply by x minus 1. We don't have an equation, so it's not like whatever you do to one side you do to the other. What we have is an expression. So if I multiply by x minus 1 over x minus 1, that's okay because I'm multiplying by 1. And if you multiply by 1, what do you get? The same thing. So I'm not changing the value at all. Okay? Now, for some of these, you will distribute. Others, you're going to have to FOIL. I only have one term here, so I am going to distribute. So 5 times x plus 3 is going to be 5x plus 15. What I usually do is I usually just make the big denominator and put my LCD in there first. Okay, and then we have addition, so that's nice. You do have to be careful when there's subtraction. But with addition, I can just add x squared. X times negative 1 is going to be negative x. And then from there, you're going to simplify. Okay, so to simplify, you're going to combine your like terms. So I have x squared, no other like terms, but I have 5x minus x, which is going to be 4x, and then I have positive 15. Okay, now if you can factor, then you do want to factor. Okay, for some of us on our homework, we would have, this one's pretty easy to see if you can factor or not, but some of them we had like 6x squared plus 30x minus 45, and we just put prime and there was no work next to it. Okay, that shows me that you are not trying to factor that out. You have to make it visible to me. So when you're factoring, like I said, this one is pretty simple to reason in your head, but I just want to model for you if you had something more complicated what you should be doing. So you know it's going to be x and x. They have to multiply to 15. So I just write my t-chart, 1, 15, 3, and 5. And then you can see, okay, if I'm adding up to 4, and these both have to be positive, there's no way. I'm going to have 16 and 8, so no, I can't factor. Again, I just want to stress, this one is pretty simple to see if you can factor or not. What I'm talking about is when you have like numbers in front of the x squared, okay, you should be making it visible to me for what you tried to factor. And since we cannot factor that any further, this is going to be my final answer. Okay, so go ahead and see if you can start part B. So the first thing you want to do is label your LCD. Okay, and Michael, what are you thinking? What's our LCD going to be for this one? X plus 4. So the denominator of the second one is technically just 1. So what you would be doing is multiplying this by x plus 4 over x plus 4. Okay, so then what I'd have, switch, is 2x minus 1, and then this is a negative, so minus x plus 4 over x plus 4. Now the reason why I just wrote this with the minus in the parentheses is to make sure that you distribute. Okay, that is something common that people miss. Whenever you have a minus, you have to distribute. Okay, so then this becomes, and usually what I'll do is I'll just write it above it so I don't have to write the entire step over again. I'll just put that this would change to plus, and it would be negative x minus 4. Okay, so you change the sign to a positive, and then you distribute. And then from there, you can combine your like terms. So I have 2x minus x, which is x. And then I have negative 1 minus 4, which is negative 5. And then that would be over x plus 4. Okay, again, those are two of the more simple examples, but your process is always the same. You find your LCD, multiply to get your LCD, simplify the top, and then cancel out if you have any common factors, which we haven't had that yet. Okay, any questions for me so far? All right, let's get into some fun things. Compound fractions. So a compound fraction is a fraction in which the numerator, denominator, or both are themselves fractional expressions. So basically it means you have a fraction within a fraction, sometimes within another fraction. Whenever we do these type of problems in 1.4, and in fact this will be like one of the directions at the top of your quiz, what we're going to do is we're going to leave our solutions in factored form. Okay, so what that means is when you're leaving them in factored form, you would be going through those 3 steps. Do they have anything in common? Is there a special pattern I can factor? Can I guess and check and factor this? You want to make sure that you are factoring. Okay, I'm going to give you A and B. That way if you finish A early, you can start on B. So for A, we have u over v plus 1 divided by v over u minus 1. Yeah, so when you have v and u, just try to make them distinguishable. After grading your quizzes, I know some of us are going to have to work on making our numbers distinguishable. Some 4s and 9s. 5 here and there looked a little suspect. Okay, so whenever you have a fraction within a fraction, ultimately what our goal is going to be is to simplify the numerator first, the denominator second, and then use what we know about dividing fractions to simplify those together. Right? So like I said, our goal is going to be to simplify the numerator. Then we're going to simplify the denominator. And then once we do that, we're going to rewrite our problem. So we'll just start with simplifying the numerator and denominator first. Okay, so we're going to look at the numerator. And we're going to get our LCD. Okay, so what I have is u over v plus 1. And please go ahead, and if you're like already with me, then you can start doing this. Okay, and Summer, what's our LCD going to be for u over v plus 1? So start with the denominator, the first one. So for u over v, what's our denominator? Yep. And then for this one, our denominator is 1. Yep. So then the LCD is just going to be 1 times v, right? Okay, so when you're picking out your LCD, I always start with the bottom of the first one, so it would be v. The bottom of the second one is 1, so it would be like times 1, which would still be v. So if I want this to be a denominator of v, I'm going to multiply by v over itself. So go ahead and simplify that. Okay, so Maddie, what's my fraction going to be once I simplify? You're close. Yes, good. Okay, so here you'd have v, u plus v would be on the top, and then the denominator is going to be the same. Okay, so again, oops, this is our numerator. So now I want to do something similar to the denominator, and I'm going to give you a minute to do this. So again, you're going to get your LCD. Okay, so I want you to get your LCD, and then I want you to simplify. Okay, so Emma, what was your LCD? Yep, so then what did you do to this? Perfect. And Emma, go ahead and just tell me what you got. Perfect. Okay, so after you simplify the numerator and denominator, what I want you to remember is that you are just dividing fractions. So we are going to rewrite this, okay? If this is my numerator, I'm going to write it as u plus v over v. And this fraction bar means division. So what I'm doing is I'm taking the numerator and dividing it by my denominator. All I've done is just simplified them. And the reason why I like writing it out like this is because then we can relate this to how we're used to dividing fractions. Because when you divide fractions, what's your rule? Yeah, multiply by the reciprocal. Remember we talked about that for bell work yesterday? When you're dividing, you multiply by the reciprocal, keep, change, flip, skip, flip, multiply, whatever you prefer. Okay, so then we're going to go ahead and keep the first one the same, and then multiply by the reciprocal, which is u over v minus u. Sometimes you're going to have cancellations, sometimes you're not. I have u plus v, I have v minus u. If I factored out a negative, would that be u plus v? No, the u would be positive if I did that, but then the v would be negative. Okay, so I'm not able to cancel those out. Now remember, we said we're leaving your solutions in factored form. So if we're leaving them in factored form, I'm going to leave this as u times u plus v on the top over v times v minus u. And that's my final answer in factored form. And we're just going to write that it is in factored form. Okay, so on your quiz, everything will have to be in factored form. Don't worry if you did distribute. If you did have u squared plus uv, what you would do is start to go through your factoring steps. And your first step is to pull out what they have in common. So you would end up factoring out that u again anyway, and you'd end up factoring out the v again anyway. So you could still get there if you distributed. Okay, if you haven't already started B, I want you to start thinking about that. Okay, so remember, just break it up so that you only have to work with one piece at a time. Okay, so the first thing that we're trying to simplify is just the 1 plus 1 over c minus 1. Okay, so for this one, Reese, what's your LCD? Yep, good. Okay, now if I'm multiplying this by c minus 1 over c minus 1, because it's 1, I know I'm going to have c minus 1 over c minus 1 plus 1 over c minus 1. Okay? And if this is a 1, I'm okay with you just jumping there. That's perfectly fine. And then when you're adding your like terms, you can see you have a negative 1 plus 1, which is 0. So what am I left with on the top? C. The denominator is going to stay the same. Okay, so then this is my numerator. Just going to put an n by it. Then we're going to do the denominator. Okay, so the denominator is similar. This is 1 minus 1 over c minus 1. So your LCD is also c minus 1. So if I'm multiplying 1 by c minus 1 over itself, I'm going to have minus 1 over c minus 1. And this one is a little bit different because we didn't have to multiply this one by anything. A couple on the front, we had to multiply both of them. So now when I subtract, negative 1 minus 1 is going to be minus 2. And then the bottom's going to stay the same. Right? And this is our denominator. So then our next step is to set up that you are dividing the numerator by the denominator. Okay, so we're going to have c over c minus 1 divided by c minus 2 over c minus 1. So you're going to skip the first one, and then you're going to multiply by the reciprocal. Now, just like what you did for homework the other night, you can still simplify if you have a common factor in the numerator and in the denominator. Okay, so I'm just going to do that in the next step so you can see it. Okay, so the c minus 1 divided by c minus 1 is going to cancel out. So then you'd be left with c on top, c minus 2 on the bottom. Okay, and that is in factored form. No common factors, no special patterns, no trinomials to guess and check. Question me on B. You guys want to try C on your own then? Okay, so for C we have x minus 3 over x minus 4 minus x plus 2 over x plus 1. And that quantity is divided by x plus 3. And then remember, if you finish that quickly, you already have your homework written down. So if you want to do a homework problem once you're done with that, go ahead. Okay, so maybe you've started to simplify the top and you realize that this one is a little bit different. So when you're doing the numerator, I know a lot of you knew that your LCD was going to be x minus 4 times x plus 1. So then what we want to do is multiply the first one by x plus 1 over itself. And we're going to multiply the second fraction by x minus 4 over itself. So when we're simplifying, we know the bottom is going to be x plus 1 times x minus 4. But then we have to think about what we need to do for the numerator. So before we just had one term and we would distribute. Now we have two binomials, so we have to do what? FOIL. Yep. Okay, so we are going to FOIL. And here we're also going to FOIL. Now you do have a minus, so I will keep that in between. Okay, so when you're FOILing, you're going to do the x times x, which will be x squared. The middle I would just do in your head. So 1x minus 3x is going to be negative 2x. 1 times negative 3 is negative 3. And then minus, and then everything else I would just put in parentheses as a reminder that we have to do what? Yep, we have to distribute. Okay, so then I'm also going to FOIL x plus 2 times x minus 4. You could distribute the negative now if you wanted and FOIL negative x minus 2 times x minus 4. I actually like doing it second because I feel like it will be quicker without the negatives. So I have 2 minus 4, which is negative 2. 2 times negative 4, which is negative 8. So then, like I said before, what I'll often do is I'll distribute and then put that above. So if I distribute my negative, this becomes negative x squared. A negative times a negative becomes positive, and then positive. Okay, so what I'll do is I'll just change this to a plus, and then I'll combine my like terms. Remember that we still are only doing the numerator here. So now that I'm simplifying, I have x squared minus x squared, they cancel out. Negative 2x and 2x also make 0. Negative 3 plus 8 is going to be 5. So I have 5 over x plus 1 times x minus 4. Okay, again, this is the numerator. Don't forget about the denominator, because that was an intense numerator that we just dealt with. So then we can rewrite it. So this is 5 over x plus 1 times x minus 4 divided by x plus 3. So now I have to multiply by the reciprocal. Nolan, what's going to be the reciprocal of x plus 3?
1 over x plus 3.
Good. So it's 5 over x plus 1 times x minus 4 times 1 over x plus 3. Okay, so then your final answer, you multiply across the top. 5 times 1 is 5. X plus 1 times x minus 4 times x plus 3 is going to be in the bottom. And this is a good time for leaving in factored form, because if not, then you would have to FOIL and distribute. Okay, so this is in factored form. We are all set with that. All right, so I'm going to give you some time right now to work on your assignment, which I did put back up there in case you didn't get it before.